All right, so I'm focusing on factoring out the greatest common factor. And the greatest common factor is something that I do cover in a previous existing video. And that one's like 45 minutes or something like that. So I didn't want to spend all that time to go over it and then not have time for factoring. So I'm going to assume that you have seen that video because I'm not going to go into too much detail on finding the greatest common factor. I'm going to focus on the actual factoring part. So the steps for factoring, there are basically two different methods. So factoring, what this means, this is a new direction that you guys need to learn. Factoring means undoing the multiplication process or undoing the distributive property. So if I have, like, let's say I'm 2 plus 3, that's not, let's say I'm distributing something like this. We were multiplying last week, A, and you're distributing it through the parentheses. So you'd have 2 times A plus A times B. You'd multiply that through. Factoring would be taking what's on the right side and undoing it. So if somebody said to factor 2A plus AB, you're basically pulling out the A that's in common and then writing what's left. So it's the reverse of multiplying. So there's basically two different methods for doing this when it comes to the greatest common factor. And the greatest common factor is what you pull out to get something that looks like the reverse of the distributive property. There's extended factoring, which we usually use with trinomials, where you end up with multiple sets of parentheses. That's where you're undoing the FOIL process. When you're factoring out the greatest common factor, you're just undoing the distributive property. So you're going to have something in front and then everything else in parentheses. So as I said, there's two methods. Method 1 is what the book uses, and then method 2 is my method. So I'm going to show both methods for a while, and then I'm going to focus on my method. But when you go to factoring, you can use either one of the methods, whichever one works best for you. And eventually you want to get to the point where you don't have to write some of these. Like, you want to be able to skip step 2 in both methods. You want to be able to just do it in your head and skip the second step. That's, if you can do that, if you can skip that second step and you can start doing it in your head, that means you are on the way to being really good at factoring. And being really good at factoring is going to make your life easier because we'll be factoring a lot and it will save you a lot of time. So you want to practice enough to be able to skip step 2, but I'm going to show all of the steps. So it's best, I can just read off these directions, but I'm going to demonstrate these on the next slide because that will make more sense. So we're starting with a simple example, 3q minus 15. So we're going to do this with both ways. So going back, the first step is to identify the greatest common factor. So that's what we're going to do first, and it's the same step for both methods. So the greatest common factor is the largest number / variable that you can divide out of every term in your expression. In this case, it's going to be a number. So our greatest common factor is the biggest number we can divide out of 3q and 15. So you're just looking at 3 and 15, and the biggest number I can divide out of both is 3. So I can't divide anything larger out of 3. 3 is the most I can divide out. And then 3 also goes into 15. So our greatest common factor is going to be 3. So for both methods, that's what you have to do. You need to identify your greatest common factor. So what method 1 does, it says rewrite each term as the product of the greatest common factor and then another factor. What this means is that you have something, you have your 3q minus 15. And we have two terms here. We have our 3q and the 15 there. And you're trying to separate it out you're trying to separate out the greatest common factor. So 3q is just 3 times q, so I can separate that out. But to get to 15, that would be 3 times 5. So basically it's saying rewrite it so that you can see the greatest common factor in both terms. So if I highlight this, we have a 3 and then a 3, so you can see that in both terms. Then step 3 is to use the distributive property to remove the greatest common factor. So that basically means, if I go back and let me do a distributive property again just to kind of demonstrate. So let's say we had a distributive property where we had 2 times a plus 4. That's 2 times a plus 2 times 4. Now normally I don't write that step. You want to get to the point where you can just do that in your head and do the multiplication. That step that we usually don't write down anymore. That's what we've created here. So we want to undo that step. So you can see that if you reverse it, that means that you end up with the 3 in front, if you kind of follow the pattern, and then you end up with q minus 5. It's like you're pulling that out in front, and then you're left with whatever is left over that goes in parentheses. So that goes in the front right here. So if I color code, if you follow the pattern of the colors, if you have it in on the right side, then you pull it in front to go on the left. So that goes in front, and then everything else is put in parentheses. And then that would be factored. So that is considered factored. We've pulled out what was in common and put that in front, and then what was in parentheses is what remains. So that's method 1. Method 2 is my method. You start at the same place. You find your greatest common factor. You identify that, and you have your expression 3q minus 15. My method has you rewrite it to kind of show some division going on, and this is using your rules of exponents. So I put the GCF in front, and then I also divide everything by the GCF. We're allowed to do that because you're multiplying in front by the GCF and dividing, so you're canceling things out, so you're not actually changing anything. We're just rewriting it. So to do that here, I would put my 3 in front, and then I would take each term and divide it by 3. So this is how I show the work. This is my method 2, basically. And then you simplify inside the parentheses, so you actually do the division. So like 3 divided by 3 is 1 that cancels, you're left with q. 15 divided by 3 was 5, and you get the same answer. And it takes the same amount of steps. It's just a different way of looking at the problems, where you look at it as multiplication, or you look at it sort of as a division kind of problem. So I'm going to do this on a second problem, just to show you what it looks like when you have like variables involved. So here we have 9st plus 7t. So first we're going to find our greatest common factor, and we first say, okay, is there any number I can divide out of my numbers? Anything in the largest thing. So out of 9 and 7, they don't have anything in common that I can divide out. My first term has an s, the second one doesn't, so I can't remove an s. But they both contain a t, so our greatest common factor is going to be t. So for method 1 here, we start with our expression 9st plus 7t. And then you rewrite it so that you have the t separately. It doesn't matter what order you put it in. I'm putting my greatest common factor in front, and then whatever's left over is in parentheses, but it doesn't really matter. So I just, first term was 9st. If I pull out the t, I have the 9 and the s remaining. The 7t, I just kind of flip-flop those. And then your last step is the t is in front, and then what's in parentheses in both terms then kind of gets combined into a single parenthesis, so that we have t times 9s plus 7. So using my method, same problem, we have 9st plus 7t. My method, I put my greatest common factor in front, and then I divide everything by my greatest common factor. And then you simplify. So my t remains in front. I like this because I can see that the t's cancel and the t's cancel. And we're left with 9s plus 7. So again, same answer, just a different method. And so it's showing you how it works, variables versus numbers. Now this is my last one where I'm gonna do both methods. And so I chose something that's a little more complicated because this is where you usually see where the big difference is between the two methods and think about, okay, which one do I prefer? So we have negative 8ab plus 24a cubed b. So our greatest common factor, you're looking for a number you can divide out of both. And if the first thing is negative, you always take a negative. So because it starts with a negative 8, I'm going to have a negative GCF. I can divide 8 out of both 8 and 24, and that's the largest thing. So I'm going to have 8. I have an a that I can remove both terms, and I can also remove a b from both terms. So our greatest common factor is negative 8ab. So now I'm going to do method 1. And you want to rewrite everything so you have your GCF, negative 8ab. And then, so notice in the first term, that is what we have. So because I have to write this as two things multiplied together, I have to add in a 1 there so that we have two things multiplied, just to set it off, because the GCF is that first exact term. So I have to add in a 1. Now, second thing, so I have a negative 8ab as my GCF. I have to split up my 24a cubed b so that I'm splitting it up so that these will multiply back. So if I have a negative 8, I need another negative to multiply to a positive 24. So I have to have a negative 3 to get to that positive 24. I have an a. I need 2 more to get me to the a cubed. And then I already have the b, so I don't have to like add 1. So I started with the GCF, and then I had to kind of fill in what I needed so that I can get back to the first step, so that if I multiplied it out, I would go back here. It was a lot easier to see when you had something similar like this, because you're basically just taking what's there. You didn't have to do much thinking other than, like here, 3 times 5. But with the one with the variable, it was already present. You were just moving things around. But here, I had to add in a 1 in order to make it the right form. And then I had to kind of figure out what was remaining in order to get back to the 24a cubed b, because you're sort of undoing the distributive property. So once you've set that up, then your GCF goes in front, the thing that's in common, so negative 8ab. And then in parentheses are the second things, and I could write this as 1 minus 3a squared. So I'm going to just highlight this so you can kind of see that I have the GCF in front, and I sort of separated those out. and then that goes in front, and then what I didn't highlight goes into my parentheses. So this is method 1 on a problem like this, and I think for something that's complicated like this, it's actually confusing, and it's really hard to figure out what the things that I didn't highlight have to fill in there in order to get it to in the correct form. Like I think that's difficult because you're kind of thinking backwards, because I had to think about what would I have to multiply by -8 by in order to get back to 24. You know, so I have to kind of work backwards. Now let's do the same problem with my method. So we start with the same thing, and I put my GCF in front, and then I divide each term by the GCF. So I just have to rewrite everything, put the GCF on the bottom. Then I simplify. So the -8b over the -8b, everything cancels there. When everything cancels, you're just left with 1, because anything divided by itself is 1. And then I have my second fraction here, 24 divided by -8, so that's -3. I follow the rules of exponents that we learned earlier. So my a, if it doesn't have an exponent of 1, you subtract those exponents. So 3 minus 1, that gives me a squared. And then I can cancel out my b's. And then there's my answer. So I got the same answer. Here it says plus and negative, but that's the same thing. Plus and negative is the same thing as subtracting. So you get the same answer. I think method 2 is easier in a case like this because you're not trying to backtrack your multiplication. You don't have to do as much thinking and problem solving and filling in the blank. You just write it and then you just follow our rules to simplify. So are there any questions or any comments on which method you prefer? You know, versus method 1 versus 2 here? Corey, do you have a preference at all between the two? You get both. Okay. There are times where knowing method 1 comes in handy. Method 2 is more useful when you move to calculus, if you have to go that far. But you can use either one, whichever, you know, works best for your brain, whatever method you prefer. I'm going to move forward using method 2 though, because that is my preferred method. So all of these remaining examples I'm going to be doing with method 2. So factor the following. So the first one on the left, 4 plus 9d cubed. So we look at trying to find the greatest common factor. So I look, is there a number that I can divide out of 4 and divide out of 9? Do they have something in common? And the answer is no. There's no number that I can divide into 4 and 9. 2 divides into 4, but it doesn't go into 9. At least not evenly. 3 goes into 9, but it doesn't go into 4. So there's no number in common. And they have no variables in common either, because the 4 doesn't have any variables and the 9 part does. So they don't have any variables in common either. So if you go through and you don't see anything in common, if there's nothing, we say the greatest common factor is 1. And if your greatest common factor is 1, that means that this is unfactorable. For the greatest common factor, basically you can't take out a greatest common factor. And so your answer, you call this prime. Because prime numbers mean you can't split them up. You can't divide anything into them. So because we didn't find anything that we can divide into these pieces that were in common, there's nothing that we could divide into them, so they're prime. So if you get something and there's no GCF, it's prime. Now, in later sections, some of these there's no GCF, but you can still factor and undo the FOIL process. But for now, anything that I show here is we're not gonna worry about that. So if you can't factor anything out, no GCF, it's prime. Now the second example here, we have 2x squared minus 6x plus 8. So we're looking at something in common. So I start with my numbers. I have 2, 6, and 8. So I can divide a 2 out of all of those. And that's the biggest thing that I can divide out because the smallest number is 2. I can't divide anything bigger than that out of 2. Then you look at the variables. So you have an x squared and x, and then there's nothing with x in the last term. So because the last term doesn't have anything with x, I can't factor out an x because I have to be able to take it out of everything. So if there's 3 terms, I have to be able to take it out of all 3 things. I can't just take it out of the first 2. It has to be everything. So our greatest common factor is only 2. So I'm going to set up my division. And usually if my greatest common factor is a number, I just skip this step because I can divide it out mentally. But I'm going to show the steps. So you put your GCF in front, and then you take each term and you divide it by the GCF. You write it as a fraction, and then you start doing the division. So like 2 divided by 2 is 1. Those cancel, and I'm left with an x squared. 6 divided by 2 is 3, so I minus 3x, and then 8 divided by 2 is 4. So we've factored out the greatest common factor, and that's as far as we can go at this point. Actually, when you have things with x squared, we will try to factor those more later on. This particular example doesn't factor any further, though, even if you tried. So this is as far as it goes. Okay, so now I've thrown a couple here with negatives in front, because we have a rule where if the first term is negative, you factor out a negative for your greatest common factor. On the homework, sometimes it won't specify this. It will just say to factor out the GCF, and it assumes a positive unless it tells you to factor out the opposite. But once you get beyond this section, section 6.1 or 6.2, it's assumed that you factor out the negative every time. It's just in 6.1 that it doesn't always do that unless it specifies the opposite. But I like to just do it every time because that's what convention is. So first problem, you always make sure that your exponents are decreasing. So it's the highest one first, and then they're going down. We want to make sure it's in standard form. And so I know because I'm starting with a negative, my GCF is going to be negative. And then I'm looking for a number I can divide out of 9, 12, and 9. So the largest one I can divide out is 3. Divide all 3 of those by 3. And then because there's an x in all 3, I can also take out an x. Whoops, I don't need parentheses there. I start factoring in my head. So our greatest common factor is negative 3x. So I'm going to put that in front, and then I'm going to rewrite everything we have divided by that GCF. Oops, I added an x squared. And always double check that what you're writing is you haven't messed anything up, added in anything extra that you shouldn't have. Like I did, I accidentally wrote an x squared. So I have a negative 3x in front. Now I'm going to simplify. So I have a negative 9 divided by negative 3. So that's going to give me a positive 3. And then we're using our rules of exponents. We are subtracting. So all the x's are just removing an x. So the x cubed means I have 3 x's, so I'm going to have 2 left over. So that's going to be an x squared. That's the same as doing 3 minus 1, and you get an exponent of 2. The middle term, 12 divided by negative 3, is negative 4. And then I have x squared over x, so that's going to leave me another x, since 2 x's are on the top. And I just removed one of them, basically. Then I have 9 divided by negative 3, which is negative 3. And then I can cancel out my x's, because there's one on top and one on bottom, so those would just disappear, basically be 1. So that leaves me with negative 3x. And then times 3x squared minus 4x minus 3. Now I'm going to move to the second example here. We have negative 3m squared minus 5m plus 4m to the fourth. We always want to rewrite these so that the highest exponent is first. So I need to actually rewrite it before I find the greatest common factor. So the 4m to the fourth would be in front. Then you have the minus 3m squared, then the minus 5. And when you rewrite it, you see that actually our first term is positive, so our greatest common factor will not be negative. We'll use positive. So greatest common factor, I look to see if there's a number I can divide out of 4, 3, and 5. And there isn't. It's just there's nothing I can divide out of all of those. So then I look at my variables. So they all have an m, so my greatest common factor is going to be m. So I'm going to put that in front, and then I'm going to rewrite each term divided by m. And then I simplify. So the numbers, nothing's happening in the numbers because I'm not dividing them by anything. But each of my exponents is going to decrease by 1 because I'm removing 1 from them. So I have 4m cubed minus 3m, then minus 5 because the m's cancel. Are there any questions on either of these two examples? Okay. Now I have this one by itself because obviously it looks a little more complicated. So, I want to make sure we have enough room. So we have 8x, y to the fourth, z to the fifth, plus 14, x to the fourth, y to the eighth, z to the seventh, minus 4, x squared, y squared, z squared. So first is to the greatest common factor. So I'm going to start with the numbers. I got 8, 14, and 4. I can divide 4 out of 8 and 4, but not 14. But I can divide 2 out of 14 as well as 4 and 8. So 2 is going to be the number that we can divide out of all of those. And then we need to go letter by letter. So I have my x's. I have an x to the fourth, and an x squared. So everything contains an x. I can remove an x. Next is the y. So I have a y to the fourth, a y to the eighth, and a y squared. So when you have multiple exponents there, if everything has a y, you want the one with the smallest exponent that you can remove. So everything contains a y, and everything contains a y squared. That's the smallest exponent. So my greatest common factor is going to have a y squared. And the same thing with the z. They all contain exponents. There's z in every term. So you pull out the one with the smallest exponent. So we have a 5, a 7, and a 2. So we're going to have the 2 in our greatest common factor. So once I've identified the greatest common factor, I'm going to put that in front. Make sure you have all your exponents correct. You haven't confused your z and your 2's. And then I take each term. I need to make sure I have all my variables and all my exponents correct, and then I divide it by the GCF. This is just writing. And 4x squared, y squared, z squared, over 2x y squared, z squared. Okay. Some people like to just start by crossing off anything in common that they can, just so they get that out of the way, but it's up to you. So next line, I have my 2x y squared z squared, and then in parentheses. So first fraction basically we have is 8 over 2, so that's 8 divided by 2, which is 4. And then we're following the rules of exponents where you subtract from top to bottom. So the x's cancel, but we have y. 4 minus 2 gives us an exponent of 2. And on the z's, 5 minus 2 gives you an exponent of 3. Plus, now I'm in the middle. 14 divided by 2 is 7. Now remember, if you just have a variable with no exponent, you can always put a 1 there. So we have x to the 4th over x. That would leave us with an x cubed, because 4 minus 1 is 3. Then y, we have exponents of 8 over 2, so 8 minus 2 is 6. And then on the z, you have 7 minus 2, which is 5. Then 4 divided by 2 is 2. And then we have an x squared over x. It leaves us an x remaining when we cancel one out. And then the y squareds and the z squareds canceled. So once you've gone through all of that, you have now factored out the greatest common factor. Are there any questions here? Okay. Here's another one that's a little more complicated. So we've got y to the 4th plus 4x cubed y to the 5th minus 3y to the 5th plus 7x cubed y squared. So I have 4 things here, but the process is exactly the same. So we need to start by a greatest common factor. So I have to look at a number that I can divide out of everything. Because my y to the 4th doesn't have a number, it's basically 1. So I can't divide anything out because there's nothing you can divide into 1 but 1. So I'm just not even going to have a number there. So I'm going to move into the variables. We usually go alphabetical order. So we got x's, but x is only in 2 of the terms here and not all 4. So because I don't have an x in every term, I can't remove an x. So that leaves the y's. We do have y's in every term. So the smallest exponent we have is a y squared. So our greatest common factor is just y squared. There's nothing else in common that we can put, nothing else we can pull out. So I'm going to put y squared in front. And then you divide each term by that y squared. So even though there's 4 things here, we're still following the same process. So if you had 10 things, you'd still follow the same process, where you take your terms, divide them by the GCF. And just, let's see, those for sure. In the last term, the y squareds are going to cancel. Nothing else will cancel out. So I have my y squared in front. Then y to the fourth over y squared. 4 minus 2 is 2. So that's going to give me a y squared. Plus, then I have a 4. I have an x cubed because we're not doing anything to x, so it just stays there. And then on the y's, 5 minus 2 is 3, so that gives me a y cubed. And I have minus 3. And then we have 5 minus 2, which gives us another exponent of 3. And then plus 7. The y squareds cancel, so we just have the x cubed. So that big, long, complicated thing is factored. So we factored out the greatest common factor. Any questions? Okay. So these are going to be my last two examples, and these are special. These are something that you get when you start going through the factoring by grouping process. And these you do similar to that first method because you can see that they're sort of set up like the first method, where you have things already in common sort of split up here. So on both of them, when the thing, it's sort of, you've got things in parentheses, those are in common. So when I have something like this, I use method 1 because I can just pull those out in front and undo the distributive property like we did with method 1. So this is the one time that that's the method that I use. You can use method 2 on something like this. I just think it's extra work. Because with method 1, whatever is in common, that's your GCF. So that just goes in front. So like we have r plus s in common in the first example, so that goes in front. And then what was left over goes in the second set of parentheses. So that'd be 3 minus 2, which actually here we can even simplify r plus s times 1. So you just are left with r plus s here. It's a little silly to factor this one, but it's just demonstrating the process. It's just undoing that distributive property. So I'll go back to the very first example where I kind of showed that. You had the same thing in parentheses on the left here. You put it in front, everything left over got in the second, or the parentheses after that. So that's what we're doing here. So the one on the right, also very simple. Whatever's in parentheses goes in front because we're undoing this distributive property there. And then whatever's not in parentheses goes instead of parentheses after that. So that ends up with 10 plus 3y. And then you're done. You've basically undone the distributive property by pulling it out in front. It looks different because it's not a single thing in front. It's a pair of things. There's two things that are put together with parentheses, but the process is the same. So the rules are the same here. And this is basically half of factoring by grouping. The factoring by grouping process will get you to something where you have common things in parentheses. That gets in front. Second set of parentheses is whatever's left over. So this is like half of the factoring by grouping process where you're just factoring out the greatest common factor. It's basically just recognizing a pattern. Are there any questions? On those problems or anything in general that I've done so far in this live? All right, sounds good. So hopefully this was helpful. made sense. Kind of gets you prepared for moving on to the next part of factoring. Factoring out the greatest common factors is the first thing we always do. And if I remember properly, the meme that I sent this week, let me double check. Yep. One says, does not simply start factoring without looking for a GCF with the Lord of the Rings, Sir Boromir. So always do the GCF first before you do anything. So this is one of the most important things this week, just because it's going to be like the first step for everything that you do that's factoring. So if you don't have any questions, that's all I've got. Thank you for joining me, and I will talk to you later.